Right, okay, so the Dijkstra then. So remember, Dijkstra's agnostic, so we put all the nodes in, infinity for everything except for the start node, picking the costs, but it doesn't know anything about relationship between nodes and the goal. Okay, so it won't get like swayed like A star has just got swayed. So we're going to pick the cheapest cost, which is A. It's got no parent. It's neighbours a B, which is 5 away, and E, which is 4 away. So let's update those. Right, picking the next cheapest, we're going to go for E. E's got a neighbour A, but that's closed already. It's got a neighbour D, which is going to cost a further 3. So that's better than infinity, so that's going to be 7. It's got a neighbour F, which costs a further 4, so that's going to be 8. So let's make sure we put the parents in. What else has it got? A neighbour. Oh no, that's it. It's only got 2 neighbours. Okay, so going round again. Next cheapest is B. It's cost me 5 already. We can get to D for a further 3, but that's not better than what we've already got. It's got another A, neighbour A, but that's closed off. But it has got a neighbour C, which cost me another 10. So that's 5 plus 10 is 15. And that's it. No more neighbours. So we're going to go through the process again. The cheapest one is D. So I'll pick it and close it off. Right, it's got a neighbour E, which has been visited. It's got a neighbour F, which costs a further 2. So that's 7 plus 2. No, that's not better than what we've already got for that one. It's got a neighbour B. Current cost for B is 5, so that's not going to be any cheaper. It's got a neighbour C, though, that is going to cost me 5 to get to. So that's 7. 7 plus 5 is 12. That is better than what it currently is. So that's 12, and that is from D. Okay. Right. What are the neighbours got? P is a neighbour. That cost me a further 1. So we've got D. 7 plus 1. So that's 8. And that comes from D. No more neighbours. Right. So we're going to go through the process again. Looking for the cheapest. We've got a 12. We've got 2 8s. Doesn't matter. I'm just going to pick F because it was the first one. Right, so F has got a neighbour E, but that's closed. It's got a neighbour D that's closed. It's got a neighbour P that isn't, though. It's going to cost me 3 to get to P, but that's not going to be better than what's already there. So 8 plus 3 is 11. So that's not better. So we've finished with that one. We're going to go through that process again. So we've got a 12 and an 8 and an infinity. So we're going to pick the P. Neighbours of P. F's closed. D's closed. C is open. So let's have a look at that. Right. So it's going to cost me 7. 7 plus 8 is 15. That's not cheaper than what we've currently got. But it has got a neighbour S, which is 10. So we got 8 plus 10 is 18. That's better than infinity. So we put that one in. Okay, no more neighbours to examine. So let's have a go through the process again. So we've got a 12 and an 18. So we're going to pick C. So you can see it's been more exhaustive than the A star straight away. Right, so we're currently at C. We've got a neighbour B that's closed, D that's closed, P that's closed. It's got a neighbour S though, so let's have a look. So we got 12 plus another 4, so that's 16. That's a better route. So we can do an update. So we got 16, and that was coming from C. Right, finished updating C's neighbours. Let's go around the loop again. There's only one item left, and it is our goal. So we've got to our goal. So let's write down S. Where did it come from? Well, we can see we updated that, so it came from C. Where did C come from? That was D. Where did D come from? That was E. Where did E come from? That was A. And thankfully, that was the start node. And the cost for that was 16. It's a different route, and it's a different cost, to the A star, and that's because the heuristic was a bit iffy. All right, because I was estimating them, but I was estimating them in a weird way that didn't take account of what the weightings were telling me. All right. Now it could be that this was a network graph, and the weightings may be the average amount of speed that you get, the bandwidth, but the heuristic could have been at this moment in time, that is the current traffic level. All right, depends. But if you do pick a poor heuristic for doing your estimates, then you will get suboptimal routes. If you pick a brilliant heuristic that is accurate, so if I'd have measured those distances, then I would have got the optimal route. But I didn't measure the distances. Okay, so that's really important as a distinction between Dijkstra and A star. Dijkstra is guaranteed to get the optimal. A star will find the optimal if the heuristic is correct. Okay.